Welcome to David Alexander Maths Tuition. This is chapter 10e, harder trigonometric equations. So first of all, we just need to make sure we're okay with some of the basics, like hopefully we can draw the graph y equals the sine of x, which would look something like that between 0 and 360 degrees. So what is the sine of x plus 1? Well, that is the whole graph shifted up 1. So we know that sine of x has a maximum of positive 1 and a minimum of minus 1. So therefore the sine of x plus 1 would have a maximum of 2 and a minimum of 0. So as we can see from Desmos here, the red line, this is the sine of x. And this is the sine of x plus 1. So the whole graph is just shifted up 1 unit. What about the sine of x versus the sine of x minus 2? Well, if the sine of x and the sine of x plus 1 meant the graph was just moving up 1, here we're just moving down 2. So the red line is the sine of x, and if we just move every point down 2, so this is just a vertical translation, the black line, that is the sine of x minus 2. So it's just affecting the y coordinates, everything is being moved down by 2. Okay, what about the difference between the sine of x and 2 times the sine of x? Well, this is a stretch parallel to the y-axis with a scale factor of 2. So what does that actually mean? Well, y equals the sine of x would look like this, with a maximum of 1 and a minimum of minus 1. So if we're just stretching it vertically with a scale factor of 2, it's just going to just stretch it all out. But we can do the sketch exactly the same, except we can just make the maximum positive 2 and the minimum negative 2. So here we have the sine of x in red and 2 sine of x in blue. So as you can see, it's a similar curve, except it's just been stretched with a scale factor of 2 in the direction of the y-axis. So what about the sine of x and the negative sine of x? So here the transformation is outside of the brackets, so it's affecting the y coordinates. So the positive, let me just first of all draw the sine of x. So the positive y values will be made negative and the negative y values will be made positive. So what we have here is a reflection in the x-axis. So it's handy just to remember that the sine of x, well, this would be the green one, and the minus sine of x, which is also, by the way, the same as the sine of negative x, the sine of minus x and the negative sine of x are the same, is this blue curve here. So it's just a reflection in the x-axis. Okay, what about the difference between the sine of x and the sine of negative x? So here the transformation is inside the brackets, so it's going to affect the x value. So any positive x value will be made negative, any negative x value will be made positive. So in other words, this is just going to be a reflection in the y-axis. So if I reflect this sine curve in the y-axis, then it will look like so. And as we can see, that is exactly the same as a reflection in the x-axis, which is why I mentioned in the last slide that the sine of negative x is the same as the minus sine of x. If you reflect sine in the x-axis and you also reflect it in the y-axis, both those reflections are the same. So here we have the green is the sine of x and the blue is the sine of negative x. Okay, so here we have the sine of x and versus the sine of 2x. So what we need to remember is this is a stretch with a scale factor of 1 over 2, so a scale factor of 1/2 in the direction of the x-axis. So if we're making everything half as big, if we're stretching it by a half, that is the same as sort of squeezing it in. So probably the easiest way to remember this is if this is the sine of x between 0 and 360, if this is 360 here, the sine of 2x means we're going to get 2 sine waves for the price of 1 between 0 and 360. So it's hard to draw them on top of each other, but I'll show you what it looks like on Desmos. But if I just draw 2 sine waves and label that as 360, that is the sine of 2x between 0 and 360. So let's just take a look. So here, the green line, that is the sine of x, and the sine of 2x. Just remember that means 2 sine waves for the price of 1. So it's being stretched in this direction, but with a scale factor of 1/2, which makes it seem like, well, it's not really a stretch anymore because it's sort of being compressed. But that's, well, because the scale factor is less than 1, it's 1/2. Okay, so what about the sine of x and the sine of probably easy to see this as sine of 1/4 x. So this is a stretch parallel to the x-axis with a scale factor of 1 over 1/4. In other words, a scale factor of 4. So that means everything's being stretched 4 times. So here is my sine of x between 0 and 360. So if I'm stretching it with a scale factor of 4 in this direction, that means I'm only going to get 1/4 of this full sine wave between 0 and 360 degrees. This is half of it, this is 1/4 of it. So between 0 and 360, I'm only going to get that initial peak. So let's just take a look. So green is the sine of x, so we can see we've got one full sine wave between 0 and 360, but only 1/4 of the full sine wave between only 1/4 of the full sine wave for the sine of 1/4 x. Notice we get half of the sine of 1/4 x when we've got the sine of x between 0 and 720, which is when we're getting 2 sine waves. There we go, hope that makes sense. So now let's solve in the range 0 to 360. So if the sine of 4x is 0.2, then I would say that 4x is the inverse sine of 0.2. So therefore 4x is, right, let's do shift sine 0.2. Oh, not sine, not cos. There we go, 0.2. So 4x is 11.53. Now remember that my next value is going to be 180 take away 11.53. So 180 minus answer is 168.46. Okay, so I'm interested in 0 to 360. And by the way, this is for singular x, not 4x. So I'm going to work out some more values. I'm going to work out the next pair as well. So what I need to do is add 360 onto 11.53. So if I add 360 onto that, I'm going to get 371.53. If I add 360 onto 168.48, I'm going to get 528.48. And so this is for 4x. So for 1x, what I want to do is just divide through by 4. Now, with experience, you'll know how many values to get. So, for example, I know, and perhaps you can get to this way of thinking, that if between 0 and 360, where the sine of x is 0.2, so let's say 0.2 is there, I'm getting 2 solutions. Now, the sine of 4x means I'm going to get 4 sine waves for the price of 1 between 0 and 360. So therefore I'm going to get 4 times as many solutions. So instead of 2 solutions, I'm going to get 8 solutions. Now, if that's too much for you to think about, just keep adding on these values until you go beyond 360. So let's assume you're thinking like that. Let's forget that I said we're getting 8 solutions. So let's work out our x solutions. So I've got this value on my calculator, so I'm going to just divide that by 4. So I need to divide all of these by 4. So I'm getting 132.12. 371.53 divided by 4, that is 92.88. 168.48 divided by 4, that is 42.12. And 11.53 divided by 4 is 2.88. So all of these are definitely between 0 and 360, but this one's miles off 360, so maybe I can get another one in, or maybe several more in. So let me add 360 to the 371.53 plus 360, that is 731.53, and when I divide that by 4, I'm getting 182.88, again well within range. Let's add 360 to the 528.48, so plus 360, that is 888.48, and when I divide that by 4, I'm getting another x value that's well within range, 222.12. So this next value is going to be the 731.53 plus 360. So 731.53 plus 360 is 1091.53, and if I want to divide that by 4, I'm getting 272.88. The next value is going to be the 888.48 plus 360, which is 1248.48, and when I divide that by 4, I'm getting 312.12. Now if I want to, I can add 1091, well I can add 360 to 1091, and that gives me 1451. So let me just work out the next 4x solution. So 4x is 1451, so therefore x is that divided by 4, and now I've got 362, which is out of range. When you're thinking of the range, another way of working out the range is if the range is 0, if x is greater than 0 but less than 360, then we can just multiply this through by 4. So 4x is between 0 and 360 times by 4 to 1440. So when you're working at these values, you can keep going until you get to one value that is greater than 1440 and then stop. But then just make sure that all these 4x values you then need to divide through by 4. So 1, 2, 3, 4, 5, 6, 7, 8. And as I said, if you start to get more experience, just think about how many solutions are you getting in if it was the sine of x between 0 and 360. If you're getting 2, then you'll get 4 times as many if it's the graph of if it's sine of 4x. Solving the range 0 to 360, tan of 2x is 7. So 2x is the inverse tan of 7. So 2x is shift tan 7, which is 81.8. Let's just call that 82, because I'm getting a bit sick of all these decimal places and all the rounding that involves. So 82. Okay, so the next one, remember for tan we always add 180. So 82 plus 180, tan repeats every 180, so that's 262 plus 180, 442. I'm going to keep going, but actually another way of seeing this range is if x is greater than 0 and less than 360, then 2x must be less than 720. So I'm going to keep going adding these 180s until I get to just below 720. So I've got 622, that's quite close. If I add another 180, that takes me beyond 720. Okay, so 2x, I'm getting 4 values, so therefore 1x, I'm getting half of 82, 41. I'm getting a 131, I'm getting a 221, and a 311. Another way of seeing this potentially, I don't want to confuse you with more methods, but if the tan of x repeats every 180 degrees, then the tan of 2x repeats every 90 degrees. So once we've got our first solution for x, we instead of adding 180, we can simply add 90. Again, I don't want to confuse things by talking about too many different ways of doing things, but I'm really hoping that that's making sense to you. Okay, solving the range 0 to 360, cos of 3x equals 0.4. So if it's in the range 0 is less than x and x is less than 360, then that's the same as the range x is greater than 0 but less than 360 times by 3, so 1080. So the cos of 3x is 0.4, then 3x is the inverse cos of 0.4. So 3x shift cos 0.4, I'm getting, again, just to the nearest whole number is 66. Okay, now for the next value, remember for cos it's 360 minus that answer there. So 360 take away 66 is 294. And my next value is this one here plus 360. So 66 plus 360 is 426. The next one is 294 plus 360. 294 plus 360 is 654. The next one is 426 plus 360. 426 plus 360 is 786. And the one after that is 654 plus 360, which is 1014. Getting quite close. Let's just check. Is the next one within range? 786 plus 360 is 1146, which is greater than 1080, so I've got them all. Another way of thinking about how many solutions we're going to get is just think about your sketch of the cos graph. It will look like this between 0 and 360, and if we're getting 0.4, which let's say is there, I'm getting 2 solutions. So if I'm getting 2 solutions for the cos of x, then what about for the cos of 3x? Well, remember the cos of 3x is the same sort of curve, except we're getting 3 full cos waves for the price of 1. So therefore we're going to get 3 times as many solutions, so 6. How many have I got? 1, 2, 3, 4, 5, 6. Done. Or nearly done. I've just worked out the 3x solutions, so now I need to work out the 1x. So x is 66 divided by 3, which is 22. 294 divided by 3, which is 98. 426 divided by 3, which is 142. 654 divided by 3, which is 218. Etc, etc. So the next one is 262. And 1014 divided by 3 is 338. There we go. So we can see that all of these are between 0 and 360. Okay, so what about solving 2 sine 2x is 0.2? Well, first of all, let's get rid of the 2. So the sine of 2x is 0.2 divided by 2, so 0.1. So therefore 2x is the inverse sine of 0.1. So 2x is shift sine 0.1. Let's just round it to the nearest whole number, 6 degrees. So the next value for sine is 180 minus 6, so 174. So now all I need to do for the next pair is add 360 to these. So that's going to be 366. The next one, 174 plus 360, 534. But let's think about how much further we need to go. So if x is between 0 and 360, then 2x is going to be between 0 and 720. Okay, well, we're quite a way off 720. Let's add 360 to 366. So we're going to get 726. That is greater than 720, so we have got them all done. So therefore x is half of 6, which is 3. 174 divided by 2, which is 87. 366 divided by 2, which is 183. And 534 divided by 2, which is 267. Sorry, these should all have degrees. In fact, all the previous ones should have degrees on as well. Okay, and again, if we think about our sketch, so let's just do 2. Right, so this is the sine of x, where this is 1 and this is minus 1. So therefore the 2 sine of x is exactly the same, except let's just call that 2 and minus 2. Okay, so for 2 times the sine of x equals 0.2, let's say 0.2 is there, we're getting 2 solutions. But if it's 2 times the sine of 2x, between 0 and 360, we're getting 2 sine waves in for the price of 1. So therefore we're going to be getting 2 lots of 2 solutions, so 4 solutions. So there we go, 1, 2, 3, 4 solutions, and we are done. Okay, so for this question we're solving between 0 and 360. The tan of 2x plus 45 is 7. So let's work out 2x plus 45, and that's going to be the inverse tan of 7. So 2x plus 45 is shift tan 7 is, let's just call that 82. So therefore 2x is 82, take away 45, which is 37. So therefore x is 37 divided by 2, which is 18.5. Now, our first solution was, when we were doing the inverse tan of 7, was 82. So the next one is going to be 180 plus 82, which is 262. So 2x plus 45 equals 262. So if I subtract 45 from that, I'm going to get 217. And then if I divide that by 2, I'm going to get 108.5. So remember that tan repeats every 180. So I'm going to add another 180 to 262 plus 180. That is 442. I'm going to subtract 45 from that, which is 397. And then divide that by 2, and 100, I'm getting 198.5, which is still well within range. Okay, so again I'm going to find the next tan solution. So the next solution for the tan of 2x plus 45 equals 7. So again we're just looking at the, first of all, the 2x plus 45. If anything, you might want to just like write lots of these down to begin with. So 442 plus 180. So we're getting 622 plus another 180, 802, plus another 180 is 982, plus another 180. Now I'm probably adding on too many 180s, but let's just stop there. Let's just see how we're going. So I need to subtract 45 from these. So 662 take 45 is 617. Divide that by 2. I'm getting 308.5. Okay, that's within range. 802. Take away the 45 and then divide that by 2. I'm not even bothering to write in the 2x value here. That is 378.5. Okay, so that one's out of range. So I'm just getting 1, 2, 3, 4 solutions here, and they are the values. So what we can do here is if the range is 0 to 360 with x, then with 2x plus 45, then the range, we could have worked out how far we need to go with the 2x plus 45 one by doubling this and adding 45. So 360 times 2 is 720 plus 45 is 760. Sorry, I've written that incorrectly. That should be 0 to 2x plus 45 must be less than 765. So any that were more than, for the 2x plus 45 line, anything that was greater than 715, that's another way we know we can stop at this point here, and therefore we're only going to get 4 solutions. So just be careful. It's better to work out too many solutions than too few. So I'd always, unless you're really skilled and you know what you're doing, always go one too far in each direction, and then you know you've got them all, you haven't missed one. In fact, maybe we should consider, is there one beneath 82? So if I subtract 180 from 82, 82 take away 180 is minus 98. But then if I add the 45, that's still going to be minus 53. And if I divide that by 2, it's still going to be negative. So sometimes, you just need to be careful. Go in both directions, just to be on the safe side. Okay, right, let's have a look at another one. So 3 cos of this stuff is 1.5. So therefore the cos of 3x minus 60 is 1.5 over 3, so 0.5. Okay, so let's think about our range. That is the same as if x is between 0 and 360, then 3x minus 60 is going to be 3 times 360. Take away 60, so 1020. So we're looking for solutions for the 3x minus 60 to not exceed 1020. So first of all, 3x minus 60 degrees is the inverse cos of 0.5. So inverse cos of 0.5 is 60. So 3x minus 60 is 60. So the next value is 360 minus that, so 300. Now I'm going to add 360 to both of these. 360 plus 60 is 420. 360 plus 300 is 660. Now I'm going to add 360 to 420 and to 660. I'm getting 780. 660 plus 360 is 1020. Okay, right, so I've reached my limit, so and it's got to be less than, so it can't equal 1020. Okay, so now all I need to do is add 60 to all of these. So 120, 360, 480, 720, 840, and we're done. And now divide through by 3. Now if I divide through by 3, I'm getting 40, 120, 480 divided by 3 is 160, 720 divided by 3 is 240, and 840 divided by 3 is 280. So I've going upwards, I've gone as far until I know I'm beyond the range, but what if there's one the other side? So what is the value below 60? Well, it's going to be 300 minus 360, and 300 take away 360 is minus 60. So I'm also getting another value of 3x take away 60 is negative 60. And if I add 60 to both sides, then 3x is 0, therefore x is 0. Can we include this one? We could have if it was x is greater than or equal to 0, but it's got to be greater than 0. So actually in this instance, we are ignoring the x equals 0 solution.